Hi everyone, welcome to my talk on testing a data science model. This area for software testers is quite new and unique, and it's an emerging area. So my aim in this talk would be to actually engage you all, motivate you, and try and persuade you to come and test a data science model. A little bit about myself. So I've graduated with a BSc honors in computer science. I fell into testing. I've got 8+ years of experience now as a software tester, and I've worked in various industries, as you can see. And some of my hobbies include dancing, yoga, teaching, and baking. The table of contents for today is what is a data science model? So I'll start from the very basics, the process around testing it, and some useful tips that you can take away with you, and some complexities that I came across that might even help you. So what do I do on a day-to-day basis? You must have heard the following words: a QA, a tester, a quality advocate. So let me not confuse you, but I'll explain to you what they are. So quality assurance are people that make sure the project is conforming to the expectations of the stakeholders. And testing is a process to explore a system and become better quality advocates. So I tend to do a lot of edge case style testing, try to do positive, negative testing, and functional, non-functional testing. And this is a small little snippet of an example that I'd like to give. So a tester orders a coffee, and it goes to the coffee shop and orders 0 coffee. So that's a negative test. And then orders a lizard. I doubt you'd get a lizard at a coffee shop, but you never know. So that's again a negative test. And these are the kind of edge case style testing that testers do. So currently, 80% of UK business are looking to hire a data scientist or seek data consultancy. IBM anticipates that data science will account for 28% of all digital jobs by 2020. So these statistics are quite good, and they make me even more motivated to call more testers on board. So without further ado, let's get started with the very basics. What is a data science model? Or what is data science first, and then the model next? So data science is a set of tools and algorithms to unveil hidden patterns from raw data. It allows decisions and predictions to be made, and the aim of making informed decision. Data science is more of like a real world scenario situation. It's more of a forward-looking approach. It's an exploratory way with the focus on analyzing the past or current data. With predictive analytics, your buzzword number 1 for the day, which I'll explain a little bit later on. So organizations use predictive analytics to find and look into patterns contained within data in order to detect risks and opportunities. So what is a model? I thought the best idea to explain to you about a model would be to give you an analogy and an example. So imagine you're driving to work. You'll get into your car, you'll put your seatbelt on, you'll turn on the aircon or some music on, and off we turn the car on and we drive. So that is your data, your driving experience. Then you get to the main road and you're stuck in traffic. Now you are thinking here, right, where can I turn left or right and get out of this traffic because I need to get to work on time? So that's the compute side of things, your brain trying different driving patterns to learn what works best. And the model side of things is an equation of data inputs affecting your target value. In this case, the target value is how long it takes for you to get to work. The sooner you get to work, your model is quite optimized. The later you get to work, your model needs a little bit of optimizing. I can give you another example. Example is for a manufacturing firm. You can check what they sold last week and check what if the same assumptions or parameters were used if the same assumptions are used, then what can be the acceptable sale for next week? So what you're doing here is you're providing sales data of a client to improve their production. So a model assesses a set of conditions and guides you to make informed decisions. Remember, a model is a statistical black box. Models use probability distribution to understand the behavior of inputs. It's more of a what if kind of situation. So if a customer uses parameters for a model suggested, then what their business could look like. Genetic algorithms. This is your buzzword number 2. This algorithm reflects the process of natural selection, where the fittest individuals are selected, and it's inspired by Charles Darwin. A model produces some indications that are being used as guidelines by our clients. And as a tester, what do? We are testing against an expected outcome here. So benefits of a data science model. It helps craft better decision making, identify opportunities, actions based on trends to help define goals. It's more of a data-driven evidence, so a lot of data goes in here. Identification and refining of target values, so you're optimizing all the time, and mimics real-life scenarios. Before we get started into the process of testing, of course, we know data science models need a lot of data. So let's look a little bit inside the data. So a model needs data, and there's 4 types of data. You have structured data, semi-structured data, unstructured data, and metadata. So structured data adheres to predefined models, which are easy to aggregate data from various locations and databases, easy to store, access, and process, such as Excel files. Then you have unstructured data, which is not organized in a predefined manner. It's got irregularities in the data, therefore quite ambiguous, such as videos and audio. You've got semi-structured data, which is self-describing data, such as tags or markers. An example of that is JSON or XML file. And then you have metadata, which provides additional information about a data set that you're using, such as for a photograph, where was it taken and when was it taken? In my project, we used a bit of structured and a bit of unstructured data. Let me give you a basic kind of architecture here. So I'll give you a little scenario and explain predictive analytics to you here as well. So imagine you have your databases and your logs and you're pushing in your raw data from there, right? And then you have your new features coming in that are being developed every other day. Now you have your learning algorithm. This is your business logics. So this is where predictive analytics come in place. So predictive analytics is the use of data of statistical algorithms and machine learning techniques to identify the likelihood of future outcomes based on historical data. Organizations use predictive analytics to sift through current and historical data to detect trends and forecast events and conditions that should occur at a specific time based on supplied parameters. So that's the bit of the learning algorithm. And then you have your genetic algorithms, which are part of your model. So with genetic algorithms, you can sometimes get a bit of randomness or something called as stochastic. So basically, your result might be a little bit different, but it's not entirely wrong. I'll explain a little bit about that later on. And then at the end, you have future-like looking data, not 100% predicted, not 100% future, but future-like. So let me give you an example as well here. So if you're providing money on credit, then the probability of customers making future credit payment on time is a matter of concern to you, right? So here you can build a model which can perform predictive analytics on the payment history of their customer to predict if future payments will be made on time or not. Right. This part, you have to be very, very careful not to be an elephant in the room. Everyone in your team should be on the same boat as you. You should not have a kind of atmosphere full of confusion, assumptions, ambiguities. Therefore, as testers, I would suggest to be involved in every part because a little nugget of information could actually do wonders when you're testing. So I would suggest be part of the requirements gathering sessions, understand the problem and the data. If you understand the data you have and how that data can be used to help for the solution of your client, then you're in a better position already. Be part of the planning sessions, brainstorm possible solutions. Design as well, be part of design sessions, prototype solutions, and evaluate effectiveness. Decide which is the most viable solution as well with the design team. Remember, as testers, we are the only people who are the closest to the end consumers. So if we understand, they should most likely understand. If we don't understand, then they won't probably understand either. So then you have your design implementation, which you can side-by-side test. You have your implementation, so you don't have to wait for a developer to finish their implementation for you to test. You can also do the testing side by side. And what I would also suggest, and I quite enjoy this, is the 3 Amigos session. So in the Three Amigos session, think from a business perspective with your business analyst, product owner, for example. What is the problem we are trying to solve? From the developers and the development side of things, you can ask, how might we build a solution to solve that problem? From a testing perspective, we can think, what could possibly happen? What are the risks? How could an implementation that a developer did impact the product? Can it introduce any bug, or has it removed any bug that we have in our code base? So let's get started. A model exists in two types. It can be off the shelf or custom made. In my team, we had a custom made model. So depending on which type of model you use, make sure you have testing processes around that. And depending on what kind of model you have. Also, consider how often you want to train your model. What I mean by training your model is input data, run the model, and learn from its outputs and results. There is a degree of randomness in a model. So let me explain to you this bit. For example, 5 plus 3 for me and you is 8. But the model might take 5 as it is, 3 as it is, but output 8.00000065. Now, when a tester looks at that number, they'll be like, right, this is completely wrong. It should be 8. Why is it such a long number? So this is where, as a tester, to gain more confidence around my results, I introduced the idea around thresholds with the data scientists. So we added a threshold of 3 to 5% that we would accept stochasticness around certain parameters between 3 to 5%. Now, if your results are too deviated, so above the 5% difference, then you know something has changed, or the model needs a bit of optimizing, or maybe the parameters you are using are not the right parameters. So according to your business, you need to think around the processes of setting target thresholds. If your business is more critical, like credit card fraud, then maybe your thresholds have to be less than 3 to 5%, so maybe between 0.5 and 1%, or less than that even. So here is the testing process that I follow. Now, verify the data set to use for your model. So check the input data and also versus your output data results. Check the shape of your data. So testing the outputs will explain if the values are of the right type and the data columns are matching or not. Test the areas you're certain about. 100% this column will match as it is in the input, it will match in the output. But also test around uncertain areas with thresholds. So this parameter is a bit stochastic, so I need to make sure it's within my thresholds. Make sure the data pipeline works as expected. So make sure no data is dropped or duplicates exist. Test using different parameters. If you test using different parameters for your model, in a way, you're doing a passive style of performance testing too of your model. So if you use certain parameters, your model might run faster. If you use the same parameters and change it slightly, your model might run very slow. So this also helps you understand the model better. And explore the model. I love exploring the model. Exploratory testing is quite interesting. You never know what you might find under there. And there might be a bug that you might not have found during a feature testing and you found during exploratory testing. So it's super, super important you do that. Some of the testing I do, again, is new features when they come in, or regression testing. So when a new feature comes in, obviously there's nothing to compare that model run with. So I work on a test plan with a data scientist. I consult results with a data scientist for more conciseness to make sure this is 100% accurate. So I analyze it myself and then I just do a recheck with them. Make sure the logic is tested as part of unit tests. Run the model prior to the new feature. So run the model before the feature and run the model after the feature and see what difference is there, or what improvement is there. And then do some exploratory testing, because if it's a new feature, then maybe there might be something that's hiddenly introduced there or not. Regression testing. This is basically to confirm a recent program or code change has not adversely affected existing feature and make sure any bugs that were found in the past are resolved. So the way I do testing here is I compare historic runs which were ran in a previous release versus a new run in my current release. So with new features in there. Remember, some models can have a degree of randomness. No equation for the best answer exists, and rely on a good enough and fast enough result. Even with the advancement of technology, 100% of automation is currently not achievable for us, as automated testing requires extensive maintenance, which is supplied through human intervention. You can obviously automate the front end side of things, which we have, but as for the model, the machine or the model will not understand the calculations I want to perform and verify. Some useful questions to think about as a tester as well. What is an acceptable test? Has a run completed and nothing broke within various stages of the model? Have we found anomalies? Are there really anomalies? Are my results that deviated or not? So you need to think around that. Also, did we drop some data? And if so, where? What part of the pipeline could be flaky? How do we know what we produced is the right result? How accurate are my results? So that comes with confidence levels, right? So you have to have some sort of precision from your delta runs. What I mean by delta run is a run that you've done in the past release and you have enough confidence that the model ran successfully. So I'm quite happy with that kind of result. And then what is an acceptable deviation? So I would suggest, obviously, as a team, set some target result thresholds, and that would help you understand your results better. So let's practice a little bit. Here is a very, very tiny data set of location and birds in that location. So you can see there are four locations, A, B, C, and D, and amount of birds in those locations. So what the model would do here is input that data, run the genetic algorithms and any business logic like predictive analytics, and show you the results in a graph format. Now, things we need to think and raise in a meeting or ask the data scientist or think ourselves and write it in our acceptance criteria is, what are we going to try and test? So this could be possible tests that we could add. How many birds were counted in the last site, for example, in D6? What is the average number of birds found across all sites? What is the total number of birds counted on sites that with codes beginning with C? How many birds do we think we would find tomorrow in site A1? Not today, but tomorrow. So we are thinking more future-like. So these are the kind of things you think. And then after that, when you've done your testing, you would think the following things. Have we got a good understanding of what has been provided? Of what the model has provided to us, sorry. Are the predictive analytics working as expected or not? And then, does the shape of my data look as expected? So by shape, I do not mean a circle, triangle, a square. I mean a histogram or a graph. Make sure there are not anomalies being found there. What I tend to do is I use the standard deviation, the mean, the absolute difference, and percentage difference to help me validate my results. Some of the complexities I've found as well that might help you maybe on a day-to-day basis in your team or when you join a data science team. So how can we mimic the client data? Initially, anonymizing few clients' data is happy, but when you have over 10, 20 clients, how are we going to spend so much time anonymizing data? That can take a lot of time, and we might even include some data biases by messing up some data by mistake. So my suggestion would be to have a lovely golden data set that you can use for every kind of client. And it has all the important features in that data set. And if you have new features coming in, then change the data accordingly to express that as well. If we anonymize data sets, we need the file size to match the client file. So what happened in my situation was we had a description of a product which was very, very long in character. So what I did was I changed it to description 1, description 2, description 3, and so on and so forth. So I was happily uploading my files onto the model, no problems, happy days, the model's running fine, my results are looking excellent. But then the consultants raised an issue. They said, we have a new client and we're piloting them, and we've got a file, but the file size is not being accepted. So obviously at that point I realized, right, they are using the raw files and it's not being accepted. What if I used the same kind of description characters instead of making them smaller, would my model still accept it or not? So these are the things you need to think about. Try and keep them as similar as possible. Then you have policies around using client data. Make sure you respect that. Model complexities. Obviously, the model is quite complex. We don't expect you to obviously understand everything. You have some sort of knowledge silos. So not everyone in your team would know everything, but if you do understand and learn something, make sure you document it so it can be there for everyone else, or set up a meeting so that everyone is on the same boat. And dependencies. So if you are making a change on the model side of things, just think, does this change also need to be impacted on the front end side of things or not? It's too late sometimes in a sprint when you realize that, right, I did this change in the back end. The testers tested it in the back end, but the test is not complete because we haven't really tested it in the front end. And then in the next sprint, you have to bring it in. So if you can think of these things ahead of time, that would be excellent. Some tips for you to take away then. Try and understand the data you're using from a business point of view. Don't derail. Make sure you stick to the consumer requirements. Review and analyze. So make sure you understand the specifications, you define your test scenarios, execute your test scripts, review, report, and document if vital. Remember, your model mimics real-life scenarios with tons of assumptions. Assumptions limit scopes, as you cannot pick all assumptions realistically, as underlying maths or algorithms will end up becoming too complex and interfere with what needs to be delivered. Be ready for discrepancies, embrace them. They're not always anomalies or bugs. By providing the statistics and facts for employee that they can access at any time, what you're doing is you're creating a smart and savvy team. Once you have a process within the team, stick to it and look on ways to optimizing it. We're not just optimizing the model here. We are trying to also optimize ourselves, our team. Be present in all vital meetings, and it's okay not to know everything. There are too many algorithms as it is. Pairing is super useful. Make sure you pair with your data scientists, developers, product owners. I call it pairing is caring. Raise your concerns. Make sure new features are being released often and bugs are not repeatable. So what does this leave me with? This leaves me with a tester who came in with a testing knowledge and has learned data science validation. So you become a hybrid tester. Some useful tools for you to look into as well. If you're using databases, then SQL would be a good option to learn. Understand some things around statistics. You don't have to be a mathematics pro, don't worry. Excel was what I used for my analysis. Developer tools to test API endpoints and front-end side of things, and Miro board to do the 3 Amigos session or some sort of collaborative work with the team so that everyone's on board. So let me quickly summarize today's session. So remember, as a tester, make sure you're doing some sort of edge case style testing and you're exploring the model as much as possible. In terms of the model, make sure it's providing accurate and precise results, and it can perform at a scale with new features coming in. It's maintainable, reliable, and testable. Thank you very, very much. Thanks for hearing my session, and feel free to connect with me on LinkedIn or Twitter. If you want to have coffee catch-ups, I'd be more than happy to explain everything through those as well. Thank you.